This is example 8.6 in Discovering Design with Chemistry. A substance is found to be 40.0% calcium, 12.0% carbon, and 48.0% oxygen. What is its empirical formula? Why is there an apostrophe in there? Okay, so we don't know what its mass is, but we do know that no matter what its mass is, 40% of that mass will always be calcium, and 12% of that mass will always be carbon, and 48% of that mass will always be oxygen. So for simplicity, we're going to pretend that we have a 100-gram sample. So we're going to start with calcium. For this, we have 40%. Well, so if we have 40%, that would be 40.0 grams. So we're going to pretend we have 40.0 grams. And then we're going to turn that into how many moles we have. So for calcium, which is right here, that's 40.08. So that means for every 1 mole of calcium, there are 40.08 grams of calcium. So by doing this, we can figure out how many moles of calcium we have. So we have 0.998 because we have 3 significant digits that we can keep. So 0.998 moles of calcium. All right, now let's do the carbon. So for carbon, pretending we still have this 100-gram sample, let's put this up here. So we're pretending that we have a 100-gram sample. So for carbon, that would mean that 12 grams of the 100 grams would be carbon. Carbon's right here. And so for carbon, for every 1 mole of carbon, we have 12.01 grams. And we can divide that to figure out how many moles we have of carbon. So this time we have so many 9s in the row that when we keep them, all we have is 0.999. So 0.999. You can see that both of these first two are very close to 1. All right, our last one is oxygen. That's right here. So again, pretending we have a 100-gram sample, that means 48.0 grams of it would be the oxygen. And for every 1 mole of oxygen, we have 16 grams. And again, we just divide to find how many moles of oxygen we have. I'm not really sure why I put that in the calculator. I knew what that was. All right, so 3, but we're going to call it 3.00 because 48.0 has 3 significant figures, so we need to still have 3 significant figures. All right, so let's slide all this to the side. So we're looking for what, oh, drat, I can't take that with me. All right, let's just slide back. So we're looking for what is its empirical formula. In other words, what ratio do each of these have to the other? So let's pick one of the small ones, particularly the smallest one. We'll pick calcium to be the smallest. And what we're going to try to figure out is the ratio of, the ratio of carbon to calcium, and then the ratio of oxygen to calcium. We want calcium to be on the bottom because just like with the other problems that we've done in recent examples, when we have the smallest number on the bottom, it makes more sense when we turn it into 1. All right. So I'm just lining up my duckies. I'm putting oxygen on the top and calcium on the bottom. And then over here, I'm putting carbon on the top and calcium on the bottom. All right, so when we simplify these, when we put the numbers in a calculator, for the first one with 3 significant digits, we get 1.00. So 1.00. That means we have 1 mole of carbon for every 1 mole of calcium. And the book doesn't really write it with this part at the bottom that I write, but it helps me to keep track of what the calcium is. The other one, we have 3 moles of oxygen for every 998 moles of calcium. And so that turns into 3.01 because we only have 3 significant digits. And so we have 3.01 moles of oxygen for every 1 mole of calcium. You can see these are very close to normal numbers. So this one is 1. This one is close to 3. And so when we put these together, CaCO, the Ca has a 1, so we don't put anything there. The carbon has a 1, and the oxygen is really close to 3. So there's our empirical formula, CaCO3.